All right, hello everyone. So this is the last video in the series. We are going to be just learning how to apply Mask RCNN to some real images and with PyTorch and torchvision. And so this is going to be a little more fun, I think, than the other videos, a little less in the weeds of the deep learning and more sort of how to actually apply this to real images, this sort of like I/O details, how to write on images and stuff like that. So let's, so here I'm on the home page of the project. We're going to go down to part 5. Let's see, applying Mask RCNN in the wild. So let's open that. So just right click this and open this link in a new tab and then save a copy to the drive. Okay, so let's jump over there. So we will use what we've learned so far in the series to apply Mask RCNN to some real images and videos. And yeah, it should be fun. So to motivate this, let's look at the Mask RCNN paper that we looked at in the last video real quick. So, you know, they're visualizing these predictions that, you know, that's not necessarily trivial to visualize these predictions like this. And so what I want to do in this video is to just show you explicitly how to do that and how to do that on your own images, right? With using PyTorch. Unlike the other videos, I'm not going to go through all of the functions and build them up from scratch. We're just going to use the package that I've written, and I'll show you how to read the docs and to like look at the source code easily natively here. But that way it's just going to be a little simpler and more lightweight. So so let's get into this. So I've got the deep learning resources here that I've had on every part of the series. Feel free to click through those. None of them are an enormous time commitment, and they're very useful. So then we've got the Mask RCNN paper that we were just looking at, and some other Mask RCNN resources, project links for this project, and some info for me. Okay, so then we're going to just start here with the installs. And as a reminder for people, the reason we're doing this like specific installs for each package is so that we don't run into conflicts in the future where different packages are updated and you know, you're just installing the default version that Colab has. So that's nice to do there. And then one thing is that I've already mounted my drive, but you're going to need to mount your drive, or at least that's the easiest way to follow along here. And that way we can put some images in the drive and run some analysis on them and get some predictions pasted on top of them. Okay, so let's start with applying Mask RCNN to a JPEG image. Oh, there we are. And I mean, it doesn't have to be JPEG, but it has to be some file type that OpenCV is comfortable opening. So the first step is to make a class map for the Coco dataset, right? So here we're just going to use Mask RCNN pre-trained on Coco, and then we are going to visualize our predictions overlaid onto our images, right? So first we have to build this class map that we've been using in all the other videos, right? Which is basically for each class, the class has a name and the class has a color associated with it that we use to build the bounding boxes and the masks, right? So I'm using this CV utility, right? So this is coming from the PyTorch tutorials library or package, and you should be able to pip install that just like this for your own projects. Okay, so the key here, well, okay, I just want to show you, like, if you hover over this, you can read the doc string. So it says, returns a class map for Cocoa classes, seed. So this seed is used to just like randomize the set of colors that are produced, and then drop background. If true, the background class assigned class ID 0 is dropped. So we drop the background class because we don't want to display that in our images. And then it returns this dictionary, right? So you can just read that right there from the docs. You can also view the source code here, and it will open this up, and you can look at the function that I've built right here, which is really nice. This works for any package that's that you pip installed or that is supported on Colab natively. So that's a really great way to track down the methods and things that you're using. But I'm not going to go into detail on this. It's pretty simple. It just builds a color associated with each class, and it just randomly assigns it a color, right? So that we can visualize things. So let's run this. Okay, so now we see like the person color is going to be mostly red, right? Actually, it's going to be purely red. The bicycle color is going to be whatever that is, right? And so on. And all these things were just assigned randomly. So that is the first step. Then let's take a pause here real quick. Okay, so now we are going to load some images into torch tensors, right? So I have this utility function. You basically just pass it the image path. So if you're running this locally, this will be like the path on your machine. If you're running this in Colab, this will be the path within your drive. And what it does is basically takes any JPEGs that are in that directory and turns it into a list of PyTorch images, right? So let's see how that works. So also here I will say, if you go back to the home page, the README for the project, and scroll down here, images and videos used in the tutorial for part 5, you can open this in a new tab. That's going to take you to just a couple photos or photos that I shared, Mask RCNN images. If you download those and put them in your own drive, then you can follow along exactly here. All you have to do is throw them somewhere in your drive and then link to them, right? And if you want, you can also check out here some examples of some processed images that I posted here, just so that people could check this out. So, this is an example of a picture I took. That's what we're gonna get towards doing, right? Is throwing some way to visualize the model's predictions on top of the images. But so yeah, download that, figure that out, or just use your own images. Throw some images in the drive, and like Cocoa is trained on many different things. So you could throw an image of like your car or of your room, and it will identify things. Okay, so yes, so now we should be all up to speed here. I'm going to run this, and then we can look at what this does. Look at the source code real quick. So it says loads all images in a directory into torch images. You need the path to a directory that only contains JPEG images or any image type compatible with CV to IM image read. And then it returns a list of torch byte tensors, right? And there's a resize factor. I put that in there because sometimes like it does get clunky dealing with huge images, so you can just resize the resolution of your image by that resize factor. So I set it to 0.5, so my images are have 0.5 the resolution that they originally did. Okay, and then yeah, all this, you can look through this, but all it's doing is globbing the files in that directory and then just turning them all into torch tensors. And here you are going to see that you need to convert from BGR to RGB when you use CV2 IM read, and then you're going to convert from CV2, which creates is native to NumPy, so it creates a NumPy array. You got to convert from NumPy, and then be careful to permute the indices because the color dimension is at the end in NumPy and OpenCV, but it's at the beginning, right? It's the 0th dimension of a torch image. Then you can resize by that factor, and that's all there is to that, really. Okay, so then we've got our images. I just made 2 different images that aren't the same shape to just illustrate how this works, and now we can visualize these. So these are some photos I took doing some backcountry skiing on Mount Rainier. I think that's Mount Adams out there. So yeah, these are our images. We're going to try to throw some visualizations of Mask RCNN predictions on top of those images, right? Okay, so all I'm doing here is loading up the model, and then I'm using this utility function get predictions. Let's look at what that does. So if we click here, look at the source. Okay, so get predictions, simple utility function for returning the predictions of Mask RCNN model. This deals with putting the model and images on device and normalizing the torch byte tensor. Okay, so it's very simple what it's doing, but it's just a nice little utility function. So we can run that and we will get some predictions. Then let's see, let's visualize these bad boys, right? Let's look at this before we visualize. Basically, we have this process images utility function, which I've built, which takes this. So let's actually move this away for a sec. So it takes images, predictions, right? That prediction that we just got, that's going to be our list of dictionaries like we saw in the last video. Then it takes the Cocoa class map and the config. So the config here is how we configure the way that we display the predictions, right? So that takes a score cut, boxes, masks, labels, those are all booleans, and then box width, box fill, mask threshold, mask alpha, so that's how transparent the mask will be, label size, so that's like you're going to print the label, how big is that, how big are the words going to be, and then the label width, that's how thick is the font. So all of those can be customized, and let's see how that works over here. So it's pretty simple. You need to have all the items in the config for it to work, and what it does is it uses those functions that we built in the last tutorial, and it displays the boxes, it displays the masks, and it displays labels. We haven't seen this displays labels function yet, but basically what this does is just draw the labels onto the images. So you can go check that out in the source code. It uses OpenCV. You can do like a put text to just draw some text on the images. So if you've never done that before or seen that before, just check that out. And yes, that is that. So and then I also have a save method, so you can just use this CV utility .save images, and we can look at what that does. Basically all it does is takes the base path where you want to save things and writes the processed images as JPEGs to that directory. And so that's where I showed the link that I shared, the Google Drive link that I shared shows some examples of processed images that you can take a look at. And you have to be careful with the same sort of things converting from Torch to NumPy/OpenCV. So okay. But let's take a look at this. This is the fun part, right? So we have these images, we want to process them, so we can start messing with this. So let's just first start off by displaying the boxes. Okay, so we've got a lot of boxes displayed here. Let's see, let's throw the labels on there as well so that we can see. Okay, so I'm going to also make this display just a little bit bigger so we can hopefully see this better. Okay, yeah, that's nice. Okay, so we've got, let's see, let's look at this. We've got skis, but it's kind of doing a double identification. Skis, more skis, person, backpack, person, snowboard, person, backpack, skis, snowboard. And then it even sees this person way back there, and I zoomed in on the image. There actually is a person back there, so it's cool that it can see things that are so far in the foreground or in the background. Also, this image is kind of weird because it's on snow, right? So I thought maybe it'll perform really poorly because I doubted that much of the training set for Coco involves images in snow, but maybe there are lots of images with snow because it's performing pretty well. So then we can start applying some, let's say we want to change the score cut, right? So we want to increase the score cut, see if that deals with some of these kind of poorly identified things here. And that actually does a pretty great job. So now it's just seeing skis there, and everything is actually pretty sensible here. So oh no, it never identified that as a person. But this is looking pretty great now. And the color of the box corresponds to the class map that we built in the beginning of the tutorial, right? Okay, so that's cool. Let's now get rid of the boxes, but throw some masks on here. So now we keep the labels and we just have the masks, right? So it's a little weird because so this looks pretty great. So the people are red, backpacks are blue, skis are yellow. And now let's start messing with the mask threshold, which I have just set at 0.5, but what if we set it to 0.87? We're probably going to see these masks shrink in a little bit, right? Let's see. Yeah, so now we're just seeing the parts where it's really sure that there is a person there, right? Or a backpack there. And so, yeah, so that gives us a sense of how those masks work and kind of the boundaries of certainty, right? So again, if we go to the other sort of extreme, we can put the mask threshold super low and see that now there is probably going to be like quite a big sort of boundary around the people, right? So yeah, so all of this is now being included in the mask. Okay, so that, and then if I just click save here, it's going to just save that to my drive, right? Right at this link. So yeah, be a little careful with that. You don't want to like write 1,000 images to your drive or something. So, but that is how that works. Let's see, is there anything that we didn't look at? Let's look at the boxes and everything together here. So we have the box fill. If you want to just fill the boxes with some transparent color that are the same color, but let's get rid of that. And then you can also change the mask alpha. So that's just the transparency. So I could make this 1, and then it's gonna just basically get rid of everyone and just have, I'm gonna make this back to a reasonable score cut. So yeah, so now let me get rid of the, no, that's fine. Okay, so yeah, you can get a sense for how this works. There's now a handbag identified. It's actually interesting. I was like, oh, it identified a handbag here and there wasn't there. But if you zoom in, there actually is a strap across this person's chest, and that is being identified as a backpack or a handbag. It's actually like a avalanche beacon, so it really is a handbag, and I hadn't even noticed it at first. Okay, so let's see. I don't like something. Oh, the mask threshold is too low. That's why things are looking weird. So let's make these back to 0.8 here. Score threshold. And then the last couple things I'll show. So we don't really want the mask alpha to be that big. It's making things kind of weird. But the label size, that's just the size of the printed label. So if I make that label size bigger, you're going to see that get bigger. So, you know, that's just a preference thing. And then the label width, you can also make bigger, which is just going to increase the thickness of those words. Okay, that's it. So I hope that's useful to people. And just as a reminder, all of these different parameters are just put into the config, and then you feed that to this utility function, and you should be able to just display those processed images with the .show method here that we built. Okay, so let's go on. Last thing we're gonna do is apply Mask RCNN to a movie, to a video. So I am gonna actually just run these real quick. This takes a second if you do all the frames of the video, but it works very much the same. You hand it the config, right? Same sort of config. I've just specified one here, and then you can run it on your .mov or MP4 should work, and then you can put it into this function, a Mask RCNN process video. So let's look at what that function does. It's a little more involved than some of the other ones, but basically you've got the raw video path, the processed video path, so where it's going to write the processed video to the device. That's going to be like your CPU or CUDA. The Mask RCNN the class map, and the config, right, which is going to specify like how you want your image to be processed. Then you can also specify the output shape, so you could make it like less resolution, frame max, so that's like if you want to only process 10 frames to just make sure things are working, and then the frames per second, which is like default is usually 30, but if you have a different one you can specify it. So it uses this OpenCV video capture, which can be a little annoying to deal with, but it works okay here. And then it basically just takes each frame, processes them just as we processed the images above, and then writes them to this video writer object that then writes the image to the path that you specify, or I'm sorry, the video to this path that you specified. Okay, so that is how that works. And so you can also put show first frame equals true just to kind of show that things are roughly working. And then I have another video that I processed here that is just the segmentation with no boxes, and then this is with everything. So you can obviously mess around with the configs and the score cuts to process your own videos easily. And you know, there are other utilities for doing this, but I wanted to build it from scratch to just learn how this works and get a better understanding of how these things work, because as things progress, like as they already are, you know, there's just going to be easy toolkits for doing this, and this might not be the most efficient way, but I think it is a good way to get an intuition for how this is working native to PyTorch. So I hope that is useful to people, and I hope it's a good introduction to OpenCV, reading through what I've got here. Okay, so I'm going to show those videos here in a second, but at the end of the video. But I'll just wrap up that, yeah, I hope this was a useful tutorial, and please reach out over YouTube or GitHub with comments on how to make this more useful, though I am trying to write my thesis coming up here, so I might not have too much time to make edits, but yeah, please comment. And yeah, that's it. I appreciate it, and yeah, I'll show those segmented videos at the end here. But yeah, thanks a lot, everyone, and good luck with learning all this stuff. All right, bye.
Yeah, Drew.
Nice. Go get it. Oh, yeah.
Nice, Drew.
Okay, so yeah, you can see that there's like an airplane and a surfboard being identified in the bottom, which is obviously not really there, but you know, these are like crash pads for climbing, which like look a lot like surfboards. And I think I didn't put the score cut that high here. Okay, yeah, this is also pretty neat. You can see that at like different aspects, like when the person is to the side, it can tell it's a snowboard, but sometimes it thinks it's skis. Pretty neat. All right, thanks for watching, everyone. That is the end of the series. I hope it was useful. and that you can use what you learn to do some projects on your own with PyTorch for computer vision tasks. Please give me some feedback on this project and the package in the comments here. So thanks a lot. Have a good one. Bye.